So for those of you that are at home, we are doing an example for balancing equations. For those of you that are in class, you already know what we're doing. Sorry, I thought I'd just break those facts for me. Okay, guys. All right, I'm on slide 7 of the quantitative aspects PowerPoint if you're following from home so you can get there. We're doing an example right now, and we're looking at writing the balanced chemical equation from words. So we're starting off from words, which is quite a tough example to start with. Okay. And the example says that aluminium reacts with hydrogen chloride solution to form aluminium chloride solution and hydrogen gas. So what we're going to do firstly, as always, is we're going to write the equation in words. Okay, so this is referred to as a word equation because it's the equation in words, and it says aluminium plus hydrogen chloride gives me aluminium chloride plus hydrogen gas. I'm sorry, the F on the end there is a problem. It should not be there. Thanks for pointing that out, though. And then, this is it in symbol form. So the aluminium is easy because it's straight from the periodic table. The hydrogen chloride is easy to write because hydrogen, valency 1, chlorine, group 7, valency -1. Put them together, ratio of 1 to 1. Yes? Then the aluminium chloride. How do we get to AlCl3, grade 10s? How do we get there? Not all at once, please. It's overwhelming. How do we get to AlCl3? Aluminium is in group 3, which means it has a valency of 3 plus. The chlorine is in group 7, which means it has a valency of 1 minus. Yes? And so now I have AlCl3. Okay. I have that, and of course my hydrogen F or hydrogen gas is H2. Are we all there? So now, as an example, I'm going to indicate each phase for the substance, and now I have the phases written down. Aluminium, S for solid, AQ for solution, AQ for solution, and G for gas. Are we all right with that? Yes? Now, we're going to count the number of atoms of each element on the left-hand side and the number of atoms for each element on the right-hand side of the arrow. So we're going to be looking at the numbers on the left versus the numbers on the right. This is a different method from what we were usually looking at. So usually we were looking at particle diagrams, and now I just want to focus a little bit on what it looks like to count it out. Okay. So, left-hand side versus right-hand side. I've got one aluminium on the one side, one aluminium on the other side. Yes? I have one hydrogen on the one side, but 2 hydrogens on the other, which is a problem. Agreed? And then I've got 1 chlorine versus 3 chlorines. That's a problem, don't you think? Okay. So let's pause there for a moment. Okay. So once we get to this point of the example, let's have a look. We're going to balance by putting a number in front of some of the formulae. Remember, when it comes to balancing equations, we can't change the formula writing. In other words, aluminium chloride is AlCl3, and we can't shift that. Okay? We can only affect the number right in the front. So what we're going to do is we're going to put a 2 in front of the aluminium chloride, so that's now 6 chlorine atoms. We're going to put a 6 in front of the HCl to balance the chlorine atoms. Then we're going to put a 3 in front of the hydrogen to balance the hydrogens, and we're going to put a 2 in front of the aluminium to balance the aluminium atoms. And that is the particle diagram that you end up with. Okay, so we have 2 aluminiums in, all right, and then we have 2 aluminiums out. And then we've balanced the chlorines and we've balanced the hydrogens as well. Okay, guys? Yes? Good. So you can write down these bits and pieces. You don't have to draw the particle diagram. Let's write that down. So notice that we put the numbers in the front and now it's balanced. So we're good. Let's try another example, shall we? Okay. So, ready? Okay. Let's look at the next example. Nitrogen gas reacts with hydrogen gas to form nitrogen hydride gas or ammonia gas. Are you ready? Write that down. See if you can write the word equation for me first. So let's look at how this example pans out. Okay? if we write this, the first thing we're going to do is write the correct formula. Let's write the words first. Nitrogen, hydrogen, nitrogen hydride, or ammonia gas. And that is the formula that we have. Okay. Now, if this is the formula that we have, we now need to look at what we put into the formula, what we put into the equation, what we get out of the equation in terms of reactants versus products. The first thing that I notice is that I start with 2 nitrogens, but I end with 1, which is a problem. Okay? And so I'm going to shift that one first. We're going to indicate the phase as we usually do, then we're going to count the number of atoms of each element on the left versus the number of atoms of each of them on the right. 2 nitrogens, 1 nitrogen, 3 hydrogens, 2 hydrogens versus 3 hydrogens. And then we're going to balance by putting the correct number in front of each substance. All right. That is the end of lesson 2, if I'm not mistaken.